Okay, hi everyone. This is the first video of the 6 weeks, so introductory video to this week's lectures and labs. Here are the things that we have to discuss this week, saying something about your homeworks, then there is a new challenge out today. Then afterwards, during the lectures, we will first look at a couple of slides regarding how people in different fields of science see network analysis or network science. Then we will discuss the scale-free property of networks, which is the power law degree distribution. We will discuss models of scale-free networks, usually called preferential attachment models. And finally, the things that the exercises that were intended for labs. Again, I will make a separate video for each of the topics, first starting with this announcement part. So regarding homework 1, it was due today. I believe that 25 or 30 people already submitted. Late days expire on Friday, and afterwards I will have a look at your homeworks. And homework 2 will be out next week, so and I will post it on Eučinica. Regarding the next challenge, let me move to the slides. So I told you everything regarding the homeworks. Again, lectures and labs will be video recorded and the links will be posted online. Now for this introductory part, we only need to discuss a new challenge. So let's look at the PDF. If you remember, we talked about measures of node importance or node centrality measures 2 weeks ago. And if we read the text, classical spectral centrality measures claim that important nodes are those that are connected to important other nodes. For example, in the case of eigenvector centrality defined as the classical eigenvector formula, measures the importance of a node as being directly proportional to the number and the importance of its neighbors. So here is a picture how that kind of measure applied to some toy network would categorize the nodes. So in most of the node centrality measures like eigenvector, cut centrality, page rank, and so on, more neighbors that you have, more important you are, and more important these neighbors are, more important you are. So the measure is directly proportional to the number and to the importance of neighbors. Now, a couple of years ago, people published a new measure of centrality, which I will now call power centrality here, which is specified according to this formula. So X is the vector of node importances, and the formula says that you multiply adjacency matrix with this vector X, where each of its entries are the reciprocal values of those of the original vector. So this X will look like as 1 divided by the value of X of the first node, 1 divided by the value of X of the second node, and so on and so forth. So going back, so in contrast to before, the importance of nodes is now positively proportional to the number of neighbors. So again, more neighbors you have, more important you are. However, it is inversely proportional to their importance. So in order to be important, you must have a lot of neighbors, but these neighbors must not be important nodes. So if we look at this conceptual figure here, this application of this centrality network to some centrality measure to some toy network, you can see, for instance, these nodes in the periphery are super important because they have a lot of neighbors, and these neighbors are not important. But the main difference is here in the center. The node in the center is again not important, although it has a lot of neighbors, but these neighbors are important. So once again, this power centrality says that important nodes are those that are connected to many non-important nodes. And one can define the centrality measure in this way. I mean, you can define your centrality measure in whatever way you want. The question is, when would that kind of measure make sense? In which scenario would that kind of measure be reasonable? So the challenge for this week is give an example of a network and a particular scenario when this power centrality measure would be meaningful. So basically, just submit to EU Čelnica what is your network, so what are the nodes and what are the links and what should this new centrality measure measure. So that is basically it. The only thing here is to come up with an idea where that kind of measure, which is somewhat counterintuitive, would make sense. If you have any questions regarding this, please post them to Piazza. So we have now taken care of this introductory part, and I will post the video here and post the videos for other lectures separately. Thank you for listening.